Welcome to this special software topic session on meta-circular and runtime code generation. My name is Herwig Mannaert, and in this first part we're going to look at the underlying concepts of this meta-circular and runtime generation. Now, when we want to create meta-circular and runtime generation, we first look at a very basic conceptual setup of a code generator. Code generators have been around for decades and decades, are as old as software itself, and basically you have some generator code, and that generator code generates code, and so you have generated code. Now we want to talk about two quite fundamental conceptual extensions to this setup and how you can implement them in a very straightforward and rather simple way. And the first extension is the meta-circularity. Meta-circularity means that the code generator and the generated code have the same underlying model. They are homoiconic from a point of view of representation. And so if you obtain that, you can turn the code generation in a meta-circular code generation, meaning that the code generator is able to generate itself as well. So the generator code does not only generate code, it also generates itself, because it's code itself. And if this code has the same structure, it is able to generate itself, which is of course a major difference, because you don't have to maintain that generator code anymore, and it has the same structure as the traditional generated code. Second fundamental extension is that if the generator code and the generated code have the same structure, allowing you to generate the generator code as well, it also becomes possible that the generated code itself is able to generate artifacts. Can be code, can also be documents, for instance, and other types of things. So if the generator code and the generated code are meta-circular, homoiconic, then the generated code is also able to generate artifacts. Now, the fundamental concept of generation is in the normalized systems platform, in the expanders, very basic. We have declaration of a modular code generator, an expander. We have data object instances, like for instance an instance data of an entity invoice, which is fed into the templates, which is kind of convolved the data instance parameters with the coding template. And so you have, for instance, a composite expander. Composite expander is declared in an XML file, and then it is declared, it uses a mapping file where the parameters of the data instance objects are made available as variables to the coding templates, and then the coding templates, which contain placeholders, variables, for instance, a package name, an entity name. Well, these coding templates, they are just instantiated, and the parameters are resolved and get a value, and then you have actual code. So this is the very basic concept that every code generator or expander in normalized systems setup works. And it's a basic convolution between instance data and templates. Now, if we look at the broader picture to understand how domain entities like invoices are related to the meta model and the metacode, we can look at a very basic representation and say we have, for instance, a data entity like an invoice, which can have a name and several attributes. That entity is implemented, for instance, in a software class. And one of the first classes you always have is a DTO, a data transfer object, a simple class representing the data attributes. So we could call it an invoice composite. And so an invoice is implemented in an invoice composite. Now, this is a class, a software class, and when software runs, when it is invoked, you get instances of that class. That class is instantiated, and you get various instances of the DTO, instances of the invoice composite for individual instances, where you have individual instance values. Now, so you can instantiate classes, and you can also read these data for these classes. For instance, you have individual invoices with individual invoice numbers or names and attributes in files, for instance, in CSV files, comma separated value files that you can edit and look at in Excel. And so you can read them in a class, for instance, an invoice reader class, and there you read the individual values of the individual invoices, and that allows you to instantiate these invoice DTO classes to individual objects. If you want to do code generation, you basically want to generate, for instance, the invoice composite class, and so you want to generate that, but in order to generate that, you need some kind of a template of such a DTO, an invoice composite of such an entity composite class, data transfer object class. You need a template, and you need also a model. You need some kind of model data where you say, well, the name of the entity that you want to generate a class for is, for instance, an invoice, and these are the attributes of that invoice. And so you need the template, you need the model, and then you need some metacode. And this metacode consists, of course, of a class representing the instances. And here you see the meta circularity emerging. You have, for instance, a DTO class representing the entity, when it's instantiated for different entities like invoice or order or customer. So the entity composite class is instantiated, and it looks the same structure. That's the meta circularity, the same structure for the domain class invoice and the model class entity. And you need then, of course, also an entity reader. And then you have the entity generator, which is a very basic mechanism in a normalized system platform where you convolve the actual instance data, the fact that the entity is called invoice and has a number of attributes, with the template. And so you can generate the domain classes like the invoice composite and the invoice reader. And so we now make it in a green color, shaded so that it's symbolically represented that it is generated and not coded anymore. Now, of course, when the metacode, the generator code, has the same underlying model and the same underlying structure, you can also generate that metacode. So this entity reader, these entity composite classes, they can be generated as well. They have the same structure. The only thing you need is that you need to have a model of the metacode, which is the meta model, but which looks completely the same. You have an entity as a meta model concept instead of an invoice as a domain model concept. And so it is the entity that is implemented using an entity composite DTO class, and you have an entity reader. And so if you have the same representation of the generator code entity and as of the domain entity, you can just use the same generator, exactly the same generator, based on then a definition of an entity instead of an entity invoice, to generate the entity composite class and the entity reader class. And then so these classes become green as well. You don't have to maintain them anymore. You don't have to continue coding them anymore because they are now being generated as well. Now, if you can generate the reader class for an entity and the composite class for the entity, it is of course also possible to generate the generator class for that entity. And so at that point in time, we don't have any actual software left. We only have generated classes that can be regenerated, that have the same underlying model, the same underlying template, and no explicit code anymore. Now, however, we can go even an additional step further, because if the generator code, if the metacode has the same underlying model as the domain code, the domain classes, you cannot only generate the generator code or the meta classes as well, you can also generate based on the normal classes, on the domain classes. So you can not only generate the entity composite, entity readers, and entity generators, but you can just as well start generating from the regular domain classes. So you can just as well have a template for artifacts based on a domain class like invoice, for instance, documents, HTML, text documents, and generate them. So you just, as when you can generate an entity generator, you can of course also generate an invoice generator, and you can start generating based on the invoices instances and generate for the various instances of the invoices text documents, HTML documents, whatever, or something else. And so you can generate these artifacts, and you can of course also generate the generator class. So now we have no code left on this entire drawing, because every code is being generated. They are all metacircular homoiconic, so the actual classes being generated, that happens in exactly the same way as the code generator classes that can be generated, and the generated classes themselves can generate as well other artifacts. And so instead of having a template class for a composite class, a composite DTO, and then having for an entity invoice generate an invoice composite, we can in just the same way have an expander for a template class, a tech invoice template, and use an individual invoice like invoice 001 to generate an actual tech or HTML invoice. And that basically enables us to have these two conceptual but nevertheless fundamental extensions to code generation or generator code, that the generator code does not only generates code, but that the generator code also generates itself, and that the generated code itself is able to generate as well. So this is the conceptual framework of metacircular and runtime code generation or expansion. There is a second part of this special topic where we actually go deeper and dive into the code and actually in 10 small steps realize such an entire metacircular and runtime expansion environment. Thank you, and you can always mail me if you have any questions.